All right, let's dive into this explainer and learn how to solve the mysteries happening right in your own backyard. Today, we're basically putting on our detective hats. You know, gardening isn't always just sunshine and blooming flowers. Sometimes it's a full-blown crime scene. You walk outside and suddenly your absolute favorite plant is wilting, turning yellow, or just randomly dropping leaves. Well, instead of just guessing what went wrong, we're going to learn a systematic forensic approach to diagnosing plant problems based entirely on the actual evidence. So when a plant wilts, we all immediately ask the exact same question, right? Why is my plant dying? And for a lot of us, the knee-jerk reaction is to instantly blame a bug or maybe a fungus. We see a struggling plant, spot a single tiny insect on a leaf, and boom, we're rushing to the garden center for a spray. But as we'll see as we analyze this data, that initial instinct, it's usually dead wrong. Because here is the absolutely crucial point you need to remember. Insects and pathogens rarely attack healthy plant tissue. A plant is almost always stressed out by something else entirely before the pests and diseases move in to, finish the job. Think of these pests not as the initial attackers, but more like opportunistic scavengers. If your plant is under attack, it means it was likely already weakened. Section 1. The crime scene. Baseline appearance. To really establish our crime scene, you first need to know what a healthy plant actually looks like, right? I mean, you can't know something is wrong if you don't know what right looks like. You absolutely have to know the genetic baseline of your host plant. For instance, plants with variegated foliage, like, say, variegated thyme or certain yellow-green hostas, they might look chlorotic or sick to an untrained eye, but they're completely healthy. They're just genetically programmed to look that way. If you don't establish this baseline first, you might literally end up trying to cure a plant of its own natural genetics. Moving on to Section 2, the usual suspects, biotic versus abiotic factors. So we can divide our main culprits into two camps here. On one side, we have biotic factors. These are the living organisms, things like fungi, bacteria, and insects that directly feed on or infect the plant tissue. On the other side, we have abiotic factors. These are the non-living environmental stressors. We're talking drought, extreme cold, poor soil, or chemical drift. The absolutely key difference here, biotic problems can actually spread from plant to plant, whereas abiotic stressors do not. Which brings us to Section 3, the twist, reviewing cultural practices. Now here is where the investigation usually takes a rather dramatic turn. We so often look up to the sky for weather problems or scour the leaves for bugs, but honestly, the true culprit is usually the one holding the watering can. Yeah, are you the problem? It's a really tough pill to swallow, but human error and our own cultural practices are actually the leading causes of abiotic stress. The way we plant, the way we irrigate, how we fertilize, these everyday actions dictate the health of the entire root system. When we make mistakes here, we completely predispose our plants to failure, essentially rolling out the red carpet for those secondary pests and pathogens we just talked about. Let's take a look at this list of common cultural mistakes. Water management is a massive one. The symptoms of overwatering and underwatering actually look deceptively similar because both cause the plant to lose its turgor pressure and just sort of wilt. Then there's planting way too deep. That leads to girdling roots that literally starve the tree over time. Oh, and don't forget physical mechanical damage, like accidentally whacking a tree trunk with a lawnmower, which rips open a perfect little doorway for pathogens to enter. And hey, beware of red herrings. When a gardener sees yellow leaves, the immediate assumption is so often a nitrogen deficiency. Let's dump some fertilizer on it, right? Actually, scratch that. Yellow leaves are frequently a symptom of poor drainage, compacted soil, or pH imbalances. Dumping excess fertilizer on a plant that is already struggling to breathe in heavy, wet soil, that's just going to cause fertilizer burn or trigger a flush of weak, sappy new growth that pests will absolutely devour. Always get a soil test first. All right, Section 4, gathering the evidence, reading the clues. Since we obviously can't interrogate the plants to find out what happened, we have to meticulously gather forensic evidence from their leaves, stems, roots, and their surroundings. Notice the really critical difference here between a sign and a symptom. A sign is the actual physical presence of the causal agent, so seeing the actual insect pest itself or spotting fungal spores and slime mold. A symptom, however, is how the plant reacts to that stress, like wilting, yellowing, or that distorted, cupped leaf you see on the right. You really need to look for both to build a solid case. If you map out your crime scene and you see uniform damage, say it's affecting all the leaves at once, or it's affecting multiple completely different plant species in the same general area, that points directly to an abiotic problem. Think sudden frost, chemical drift, or, again, our own cultural practices. But if the damage is random, scattered, or clustered on one specific plant family, you're very likely looking at a living, biotic pathogen that's spreading naturally. And remember, timing is everything in an investigation. Ask yourself, did this happen overnight, or has it been getting steadily worse all month? Sudden damage is almost always an abiotic event, like a harsh cold snap or an accidental herbicide drift. But if the symptoms are developing progressively over weeks, slowly colonizing the new growth, well, that indicates a living, reproducing pathogen. Consider a tree suffering from what we in the Viz call decline. Decline is the slow, years-long death spiral. It is rarely just one single thing. It's a complex puzzle of interacting factors. But very often, it's triggered by an abiotic cultural issue from years ago, like severe root damage caused by construction equipment driving over the root zone. That gradually starves the tree, making it incredibly susceptible to opportunistic rots years down the line. Section 5. Subterranean Diagnostics. The autopsy. To truly understand what's happening below the surface, especially if a plant is wilting despite the soil being perfectly wet, we have to perform a bit of an autopsy. The root zone is the most challenging area to diagnose, simply because we can't easily see it. So one of the absolute best ways to test your cultural soil conditions is the incredibly simple screwdriver test. You just take a standard screwdriver and try to push it into the top 6 inches of your soil. If you hit what feels like a literal brick wall, well, you've just discovered your problem. Your soil is heavily compacted. When soil is compacted like that, roots literally suffocate from a lack of oxygen, and they cannot absorb water or vital nutrients like calcium, no matter how much you water them. Moving on to Section 6, the disease triangle, how infections take hold. Now, let's say you've checked your soil, your watering habits are completely flawless, and the evidence definitively points to an infectious biotic disease. You need to understand how that disease actually functions in the real world. I absolutely love this concept, the disease triangle. It states that an infectious disease literally cannot take hold unless 3 things are present at the exact same time: a susceptible host plant, an active pathogen, and an environment favorable to that pathogen. What's so empowering about this is that by simply altering our cultural practices, like spacing plants further apart for better airflow or watering at the base of the plant to keep the leaves dry, we can completely break the favorable environment side of that triangle. Break just one side and you stop the disease dead in its tracks. Section 7. The final verdict. Making the call. Okay, we have gathered the evidence, mapped the distribution, analyzed the timeline, thoroughly checked our own gardening habits, and evaluated the root zone. Now it's time for the final verdict. When making your management decision, keep these key takeaways in mind. First, don't guess, let the symptoms lead you to the diagnosis. Second, critically evaluate if the damage is merely cosmetic. Seriously, a healthy deciduous tree can actually tolerate losing up to 1/3 of its total leaf surface before it experiences any real life-threatening stress. So try to avoid reaching for broad-spectrum chemicals that might kill off your beneficial insects. Sometimes, the absolute best cultural practice is simply accepting a little cosmetic damage and letting nature take its course. And occasionally, it means accepting that a plant is in severe decline and just needs to be removed. So as we wrap up this explainer, I really want to leave you with a final thought to ponder the next time you step out into your garden. When things go wrong, ask yourself, is your plant truly a victim of some vicious pest, or is it actually a victim of your own cultural practices? Before you reach for that bug spray, maybe grab your magnifying glass instead. Ask yourself this forensic question. You might just save yourself some money, save a whole lot of beneficial insects, and become a master garden detective in the process.